Hi. Here in this video we are going to see how we can use Cuckoo Optimization Algorithm to cluster our data. Here in this folder we have a sample data named as data.mat, which we can see as X and Y. Of course we need to use star. We have such data in our data file. As you can see, we can cluster these data into four groups. But we need a Cuckoo Optimization Algorithm to find center of these clusters optimally, so that the distance between these data points and those centers be minimum. For this, we have a cost function named as cmeans cost, which we will see it's written here. We have number of clusters. We have 4 clusters here. Number of parameters that COA or Cuckoo Optimization Algorithm is going to optimize will be as double of these number of clusters. That's because each center has a X coordinate and a Y coordinate. So we will have 8 X and Y's, in total 8 parameters to be optimized for cluster centers. Where low, lower bound of the Cuckoo Optimization algorithm and higher band will be found automatically by searching the minimum values of X and Y's inside this data file. Similarly, the higher bound will be found automatically by maximizing X and Y values in that data file. Other parameters of COA will be chosen as in its default, like 5 cocos in total, 2 eggs for each cocos in minimum situation, and at maximum situation it will lay 4 eggs. Number of iterations, here I've set it to 100, and number of clusters is something you will choose. 2 is enough here, we can choose it as 1 either, and other parameters here can be chosen, or you can leave it as it is. The cost function we are going to optimize here to find the optimal centers for each of these 4 clusters is written in cmeans cost. This is an easy cost function here. We will send a population of candidate parameters in 8 columns, which we will divide it by 2 here, as you see. First half of the parameters in each row of this population matrix will be X coordinates, and the second part of this population matrix will be our Y coordinates. We will use these X's and Y's here to find the distance from each data point in our data file. As you know, in cmeans algorithm, the minimum distance of a data point and a cluster center means that that data point belongs to that center and to that cluster. And here we will calculate the distance from each data point to the centers that COA is proposing. Our next step is to define a punishment for COA just in case it ignores using one of the clusters, and let's say it produces 2 or 3 clusters instead of 4. This little loop here will punish COA, so it uses and divides all these data into 4 clusters. Our total cost value will be calculated as summation of these distances found here and this punishment calculated here. This punishment is initially set to 0, so if just in case COA uses 4 clusters to group data, it will remain 0 here, and we will optimize the distance of data points and the cluster centers. This will lead us to the compact clusters. So we go back to Cuckoo main code, and at the end of this Cuckoo main or Cuckoo Optimization Algorithm codes, we have written the cost function again, but this time we will use optimal Cuckoo habitats to have the ideal for centers, for clusters. Then we will find the minimum distance of each data point with each cluster center, which means that data points belongs to that cluster, and then we shape the clusters here with those x and y values in our data points. When the clusters are shaped, we can plot them and display them on a command window, and also we can plot them on a figure to have a better view of what's happening. To run this code, we can go to editor and click the run button. As you see, the cost function value starts to get minimized, and when it's reached to 100 iterations, it will stop, showing us clusters. Here we have 4 clusters here. Cluster 1 with these data points in our data file, cluster 2 with data points assigned to that cluster, cluster 3 and cluster 4 as well. And these are the ideal cluster centers for each of these 4 clusters and groups shown up here. And as you see here, we have 4 clusters in different colors with optimal centers of C1, C2, C3 and C4 for different groups. That's how you can easily use Cuckoo Optimization Algorithm to group your data for any number of clusters. If you wonder what is Cuckoo Optimization Algorithm, I will leave you a link in under this video which you can click on and visit the page for Cuckoo Optimization Algorithm and its details, or any questions you can write there and mentions, and I'll answer you as soon as possible.